Today we began writing proofs to solve algebraic equations, and so this involves more than just identifying the value of the variable. It involves citing the property that you use on each step of your solution, and we went over each of the properties today in class and on today's notes, and they're also listed at on the front of your homework, so as a reference. And between the two problems I'm going to do with you on the homework help video 5 and 6, if you watch those carefully, if you're having any trouble and you watch those carefully, you should be able to apply those ideas to problems 1 through 4. So everybody should be able to complete these proofs on their homework. The first equation we have says d divided by 16 is equal to negative 24. The whole idea of solving an algebraic equation is you want to isolate the variable, because if I can just get d by itself on one side of the equation, then I'll know d equals whatever's on the other side, and then I will have identified the value of d. So we have to undo whatever's happening to the variable on the left side of the equation here. Here we're dividing by 16, and the inverse for dividing by 16 is multiplying by 16. So if I multiply by 16, I can undo that division. And then think about it this way. If you had 32 divided by 16, that would equal 2. And then if you took 2 and multiplied it by 16, you'd get back to 32. Division and multiplication are inverse operations, so one undoes the other. And so we can figure out what d is by doing the inverse of dividing by 16, which is multiplying by 16. But if I multiply the left side of the equation by 16, I need to also multiply the right side of the equation by 16. That's the property of equality that we went over today. So you have to write down the property you use for each step of your solution. The property of equality is that balance scale model that we looked at in class. You can do anything you want on one side of the equation as long as you do the same thing on the other side to keep the equation balanced. And the reason we multiplied by 16 is because 16 sixteenths equals 1. You have 16 over 1 multiplied by d over 16. The 16s cancel, and you end up with 1d. The fact that 16 multiplied by 1/16 equals 1, that's showing that reciprocals have a product of 1. So that's the multiplicative inverse. So we'll show that in a second, but first I just need to find out what this product is. 24 multiplied by 16 is 2 6s is 12, plus 2 is 14. Now I'm multiplying by 10, so I start with a 0 in the ones place. 4 tens is 40, 20 tens is 200. So I get 348. Did it wrong, 384. So 1d, and then I have to think about the sign. A negative multiplied by a positive is a negative, so negative 384. But the property that we're using here, the reason we multiplied both sides by 16 is to take advantage of the multiplicative inverse. Anytime you use multiplication to undo division or division to undo multiplication, you're multiplying reciprocals, and that's the multiplicative inverse. 1d is d, so d equals negative 384. The fact that 1d equals d, that's the multiplicative identity. Multiplying by 1 doesn't change the value, doesn't change the identity. So once you know what 1d is, you know what d is. And so d equals negative 384. But we would never stop there. We would always verify our solution. So I already wrote the verify. If you look on your homework, I rewrote the equation for you. Normally you would need to do this for yourself. You start with the initial equation, and then you substitute in the value that you think d is. You think d is negative 384, so you substitute d for negative 384. And that property is substitution. Anytime you substitute an expression for an equivalent expression, that's substitution. Now, we hope that when we do this division, we get a quotient of negative 24 so that both sides are equal. But it's not sufficient to just write negative 24 here. You actually have to do the division. Otherwise, you're not really checking. So 384 divided by 16. How many 16s are in 3? 0. How many 16s are in 38? 2, because 2 16s is 32. Get a difference of 6 and bring down the 4. There are exactly 4 16s in 64, with a remainder of 0. So the quotient here is 24, but we were dividing a negative by a positive, so that gives us a negative quotient. So negative 4 equals negative 24. That's what you're hoping to see. That checks that you actually have the correct value of D. That's called the reflexive property. It's like negative 24 is looking at its reflection in a mirror. But never assume that this is just equal to negative 24. You actually have to do the operation. Because what might happen sometimes is you'll get some quotient that's not negative 24, and that's not a bad thing. That gives you the opportunity to go back and check your work and figure out what went wrong. Maybe it was a computation error here. Maybe you used the wrong operation to isolate the variable. But it's not a bad thing if this doesn't work out. It actually gives you a chance to go back and fix your mistake. I also want to do problem number 6 with you. H minus 81 equals negative 22. Again, we're going to use an inverse operation. We want to do the inverse of subtracting 81. So what's the inverse of subtracting 81? You add 81. And you have to add 81 to both sides. What property is that? What property did we just use when we added 81 to both sides? That's the property of equality. Now h minus 81, do it over here. Subtracting 81 is the same as, subtracting is the same as adding the opposite. So this is the same as adding the opposite of 81, which is negative 81. So I want you to think about this. When we did negative 81 plus 81, what property were we using? And what would the result be on both sides of this equation? Refer to your properties, do that during the pause, and try to complete this on your own, and then come back and see how you did, please.
Paused.
When you add opposites, you get a sum of 0. So h minus 81 plus 81 is h plus 0. Adding opposites gives you a sum of 0. That's the additive inverse. Anytime you add to get rid of a negative, or you subtract to get rid of a positive, to make that sum 0, you're using the additive inverse. When you add to undo subtraction or subtract to undo addition, you're using the additive inverse. So we just need to think about then negative 22 plus 81. If I think about a number line real quick, if I think about, okay, 0's here, and I'm at negative 22. If I add 81, which direction am I going? I'm going to the right if I'm adding 81. But adding 81 is going to take me way past the 0, right? I only need to add 22 to get to 0. So I'm somewhere in the positive territory here. And we find the difference between these two to find out where we end up. 81 minus 22 is 59. So I end up at positive 59. So negative 22 plus 81 is 59. So then h plus 0 is 59, so h is 59. H plus 0 is h, the identity of h. So this is called additive identity. You can add 0 without changing the identity. And so that's the additive identity, but we still need to check our work. So here's our verify step. We start with the original equation, h minus 81 equals negative 22. And then we substitute what we think is the value of h, 59. 59 minus 81 should equal negative 22 if we did this right. That's substitution. And then, you know, we can use this same number line for 59 minus 81. If you think about it, if we start it instead at 59 and we subtract 81, that means we're going, if we're subtracting positive 81, we're going 81 in this direction. So you find the difference between 81 and 59. Which is 22, and you just realize if I started at positive 59 and I went 81 to the left, that's going to take me past the 0 into the negative. This negative 81 has a greater absolute value than 59, so it's going to be negative 22 equals negative 22, and that's the reflexive property again. That's how we know we have the right value for h, because we ended up seeing the same value on both sides of the equation, indicating that the equation is true. Okay, I hope that helped, and I hope that helps you do 1 through 4 if you're having any trouble with those.